an amazing feat. And first things first, let's get done with the intros. So as you heard, my name is Mohammed al-Sahaf. I answer to Mohammed, I answer to Sahaf. Everybody calls me Sahaf, so you can call me Sahaf. Product manager by day, and you can find me online here. So let's get real. So now, who likes to code in C? You're at the wrong place. Nobody should. Buffer overflows, all kinds of memory issues, manual memory management, and all that mess. You shouldn't. Here we are in Golang. We're promised that it is the promised land. You don't need to care about C. You should only look at this bright area where the light shines, and you should never go to where C is. But can we avoid C? See, when you deal with the operating system, there's a libc provided by the operating system. They are the ones, or the libc is the one that manages the Syscalls, which are the special functions provided by the operating system. Moreover, the TLS and SSL stack for most of programming languages rely on OpenSSL, which is written in C. And the final example I have here is that actually in PHP, the HTTP client relies on the libcurl implementation, which is in C. Now, but we are in Go. We should not care about all the C stuff. So in Go, we're told that if you set CGO enabled to 0 and you build, Bob is your uncle. You will not have C in your stack. Is that true? Well, let's look at that. Let's see if we disable or enable CGO, what's going to happen to 3 examples. And from there, we will see what kind of trade-offs or benefits, advantages, disadvantages are we gaining or losing throughout. First, we have a look at the OS user package. The package offers a set of functions that will help you look up users, groups, interacting with the user systems and the operating system itself. Now, to take you through this thought experiment, we'll assume that we're building an authentication microservice that relies on the user existence on the operating system. So let's assume you're building an SSH server, so the users that's logging in should exist in the operating system, and if the user credentials, the user exists, the user credentials are right, in the operating system itself, you let them in. So this is the typical code you're going to write. But what is this going to print if you build it with CGO disabled? What will this code print? So this is not the current user. This is a different user on the operating system. What is this going to print? Now, this is the guest user. It's a special user created on the operating system. To know how the standard library is going to behave, we have to read the docs. So what does the doc say? The doc says that for most operating systems, the package has 2 internal implementations. One relies on libc, one relies on Syscalls, calling the get pwid and get our name, etc. And the other one is pure Go implementation. So when you disable CGO, you go to the pure Go implementation, and you're supposed to get the same results, right? Well, maybe. Now, we end up with 2 sets of matrices. It's hard for me to do a 3-dimensional matrix in here, so I had to split them into 2. Now, we have a case if it's a current user, not current user. Are we current user using OS user Go, the Go implementation, the pure Go implementation of the user lookup, or not using the OS user Go? Is CGO enabled? Is CGO not enabled? What are we looking at? And you end up looking at this zoo of results. See, the implementation is kind of a bit consistent when you disable CGO. And then you look at the other side. Oh, and you look down here when you enable CGO, and the results vary And it's when you disable CGO versus when you enable it, the results are slightly different and slightly annoying because I'm supposed to rely on the standard library to give me consistent behavior, but it isn't. Now, I'm annoyed with the Go team. They learned that I'm preparing this talk over the variances between CGO enabled and disabled, and it involves the OS user lookup. And they changed the behavior with Go 20. When I planned all this, it was Go 119. There are some good news to that, because in Go 120, it's a bit more consistent. So it fills the gap in here, and you have the same unknown user. It's going to happen in both areas for the not current user with the pure Go implementation. Now, I have to tell you this. This is on Darwin. This is not on Linux. This is not on the BSDs, and not on Windows. So in Darwin happens to be a special case, because in Darwin, on Mac OS, the users, the additional users that are created, if you have another user called John, it's not in the etc password file. It uses OpenLDAP, which means it has a different database. But the pure Go implementation of OS user Go parses the user etc password file. And this is where the variance comes from. So the Go team had to change it. And now they do a syscall to look up other users if you do not use the OS user Go build tag. So even when you disable CGO and you do not use the OS user Go tag, it's going to have a syscall that to fetch the user. So brings us to the next question, or the next adventure. Are syscalls libc free? And what happens if they are or they aren't? Well, so I did talk faster than I should have, and this is where the variance comes from and the change in Go 120. So as of Go 120, you have these build tags that will cause this syscall, whether you have CGO enabled, disabled, and whether you're using OS user Go or not. And you see the special tag for CGO Darwin, not OS user Go, and the same here. And this is where I skipped to syscalls, because now we have to investigate. Do syscalls require CGO enabled and disabled? And if it isn't, how does it work if I disable CGO, but syscalls are done through libc of the operating system? Now, first, we have to be all on the same page. What are syscalls? So we can think of syscalls as the standard library of the operating systems. It gives you a set of functions to do some common tasks. The kernel or the operating system will do them for you, and will provide you with results. They're special interface given to the user by the operating system. Now, in Go, in the beginning days or the early days of Go, syscalls were implemented directly in Go. In other words, people say, or it was stated as such, Go used to make cross syscalls to the operating system. That was in most Unisys, and there is a good reason for that. They didn't just do it because they liked doing it. They liked to do it. No. Having to interact with C in your Go code, it makes it awkward to handle this shift in context. And it makes Go more solid because you only have to care about this Go ecosystem and don't have to care about libc. And this was supported by, I'm not going to quote Linus Torvalds directly because his language is kind of not suitable, but there's this big rule: we do not break user space. And user space to the Linux kernel is the syscalls interface. And Linux provides stable ABIs, not APIs, but ABIs, application binary interface, which means the syscall number is not going to change across versions, which is the syscall pointer. Now, we have to study all the ports that Go has, more or less, because we want to investigate, is the syscall interface stable across them, and does it use CGO across them or not? And we're not going to focus on all of them, because the Go team has decided to distinguish 3 ports of all of this. So for Darwin, Windows, and Linux, they call them first-class ports, which means even if we have an RC version, if the build for one of those breaks, the release is frozen. It's not released until this is fixed. So we have special attention to those 3 ports. Now, on 2 of them, Go makes syscalls directly, Linux and FreeBSD. And we know on Linux the case is more or less stable because the Linux kernel developers promised to give us stable ABIs. The syscall interface is not going to change, it's going to stay the same, and nothing is going to break. If you have a Go binary built today, and in 10, 15, 20 years, if the Linux kernel stays in development and still running, your Go binary is still going to be running, delivering the same results. Of course, caveat, given that the same semantics have not changed. Not the interface or the syscall number, but the semantics, which is not something that we can account to in the APIs. Now, the other 3 ports, and I'm going to give OpenBSD special attention because it's kind of neat. Now, in OpenBSD, Go used to do the same thing they did with Linux, which is making the syscalls directly. But they introduced something called system call origin verification, which means you, as an executable, you are not allowed to make syscalls directly from your own memory page. It has to come from a designated location, which they know is secured. And this is secured because certain implementation by the OpenBSD devs, it's not related to this talk, so we may skip, but what's related is that this means that Go cannot make the syscalls directly anymore and has to call libc of OpenBSD. Now we are at odds because if you disable CGO and OpenBSD requires libc to make those syscalls, how are you going to do anything on OpenBSD? Because sooner or later, you're going to need syscalls. Printing, making network calls, listening on some socket, those are all syscalls. Now, OpenBSD gave a heads up to the Go team to change the implementation. They gave a special treatment to the Go binaries for a while, allowing for the migration. And the Go team started on working on this. As of Go 1.16, the syscalls are made through libc on the AMD 64 ports, and they're working through the others. The other ports, so x86 and ARM64 and all of that, are still work in progress. Perhaps they finished, perhaps they not. I care about AMD 64. Now, on Darwin, they had similar case, but slightly different. Now, in Darwin, they didn't have the system call verification, origin verification, but Apple considers the syscall interface to be private API. It's there, but you're not expected to call it. You're supposed to use libc of Darwin. And if you use the syscall interface directly, Apple's not going to support you if that breaks, if your application or software breaks at any point in time. This means that the Go team had to port their implementation to move away from making the syscalls directly into using libc of Darwin. Now, just like the case with OpenBSD, this puts us in an awkward position. Are we using C or not? And what if we disable CGO? What's going to happen here? Now, the thing is, you'll still end up with libc one way or another on Mac. And on OpenBSD, you're still going to end up with libc one way or another. Even if you disable CGO, libc of OpenBSD is going to still be there, and that's the only C code that's going to be in your final executable. Same thing is going to happen in Darwin, but slightly different because the promises are different. And the libc that's provided by the Apple implementation is kind of virtual. You didn't see it there. You're not going to find the files on your operating system. Now, the third one is Windows. And Windows is also a slightly different case because it doesn't give you a libc, but it gives you a DLL, which is similar thing. It's a dynamically loaded library, and it's the interface that you use it through or make the syscalls through. But there are different files. However, all the syscalls come through kernel 32. And we can consider this as the libc of Windows. Now, what this means that this is lazily loaded. The C code is not going to be in your executable itself, but when you run your executable in Windows and you make a syscall, it's going to load this library and make this call, which means it goes through C code because this is a dynamically linked library built from C or C++ code one way or another. And if you will look at the runtime files, the files for the runtime package for Windows, we see a special linker directive all over the place saying cgo import dynamic and then a function name and then a symbol name. And what that does, this is a special instruction for the Go linker to take that symbol name, and whenever it loads the DLL, it's going to find that function or syscall and links it to that special symbol name, which means when the runtime calls the symbol, it's going to direct that to the C implementation or the DLL function through that, which means we end up having libc of Windows, more or less, going through that. Now, CGO is disabled. We still have that. Now, our next is to look at the net package, because again, we're building a microservice, and we're going to have to deal with net, not this net, this net. Now, what's wrong with net? What's wrong with net if you disable CGO? Of course, it's going to be DNS. There's no other thing that's going to break at any point unless it's DNS. Now, DNS is the root of all problems, the root of all evil, but now we need to know what happens to DNS and the net package when we disable CGO. Is it just going to stop working? Of course not. If we're using Go executables that's built with CGO disabled all the time, they're working. They're not broken, are they? Well, it depends. Just like all engineering questions, the answer is it depends. But first, just like we did with the OS user package, we're going to have to see what the doc says. Now, the doc says the resolver it's using on most Unix systems, it has two implementations. It has CGO related functions called fallback functions, and it has the pure Go implementation. And depending on complex criteria, it's going to route the function call or the resolution request to one or the other. And if we look at it, it's quite complex. We have 1, 2, 3, 4, 5, 6 criteria to consider to know, is my function call going to end up in the pure Go resolver, or is it going to end up in the CGO resolver? Now, CGO resolver calls those syscalls, get adder info, get name info, but I hope the implementation is the same. If I resolve example.com, is it going to give me the same IP address every time? Well, the trick or the catch is here. Now, MDNS is a special implementation or a special extension of DNS to resolve local area names. And this is where the pure Go resolver fails. And if we run our application with the netDNS Go or netDNS CGO, and we try to resolve an MDNS domain name or host name, it's going to give you slightly different results, because the Go implementation does not manage MDNS, and it relays those calls to the C implementation. But this is not the case on all operating systems. Again, just like everything in Go, we have a caveat with Plan 9. The resolver will always use the netcs and netDNS. But what's going to happen in here, and as you can see, we can force it one way or another, but this is, just like everything in software engineering, this does not come for free. If I use the pure Go resolver, this is not a free of cost decision, and neither will it be if we disable CGO. And even if you disable CGO, you can still end up with the CGO calls of our DNS resolution. Now, what kind of mess are we in? We see here, here's an example, and this is not, well, I don't have a good contrast in here. I have this simple code. I'm simply calling google.com with a GET request. I build it. This is a Linux machine. CGO enabled is 0. I build it. I run LDD to find any dynamically loaded libraries in there. And I have dynamically loaded libraries. What's going on there? Now, because I didn't specify for the Go compiler that I want the pure Go implementation of the DNS resolution of the net package, it will still have the CGO fallback calls, which means it still needs to make those calls through the CGO, the libc interface, and it means even if I disable CGO, I still have the libc in my binary. It's quite an awkward position to be in, but we can avoid this if we set tags netgo, and I tell the compiler that I want the pure Go implementation in my net package. Now, this does not extend to the OS user Go build tag we've seen earlier, which means if you want both implementations to be pure Go at all times, you're going to have to set netgo and OS user Go in both ends. Now, this indicates that CGO enabled equals 0 will not always give me a CGO free or C free binary at the end. It's quite strange because this is contrary to the promise we've been given at the beginning. We're told if you don't want any C in your code, you set CGO enabled equals 0, and all of this is out. But it isn't. And we're not happy, are we? So we dig further, and it gets worse. It gets a bit worse. If you do lookup post for all of these, and these are compliant IP addresses. If we look up the host for all of these on Darwin and Linux, we're going to see different results. And with netgo or netCGO, we're also going to see different results. Here, we have with CGO enabled equals 0, netCGO, which means we disable CGO, but I'm using the netCGO, which means it's going to go through the CGO, and we have null here for this resolution, and no such host for the other. Here, when you have the pure Go implementation, CGO enabled, again, this is quite a paradoxical scenario, but still works. You run it, and still runs and gives you a result. The compilation does not fail. And by the way, this is the correct results. This is what Linux runs. And this is actually not my findings. This is one of the open bugs on the Go issue tracker, and still up for discussion and open for everyone to study, and the Go team is still discussing the resolution for this one. Now, what does this mean? What are you saying? Should I disable CGO? Should I enable CGO? What am I supposed to do with this executable? Will disabling CGO give me a fully static build? Well, depends. As you've seen on Darwin, you build it with CGO disabled or CGO enabled equals 0, and you still have libc running through that. On OpenBSD, you still run it with CGO enabled equals 0, and you still have libc going through that. On Windows, you build it with CGO enabled equals 0. You have the DLLs, which is the libc running through that. So it's not always the case. The only one that's a bit more consistent is the Linux build. So on Linux, you set CGO disabled equals 0, and assuming you're using netgo build tag, you're going to have a fully static binary. On other operating systems, it's going to vary. It's quite awkward. It's not something that the Go team can avoid completely. However, these are things that you have to consider in your build and in your project. See, on Darwin, whatever you do, you're still going to have dynamically linked libraries going on there. The O tool is equivalent to LLD on Linux, and no matter how you play with the parameters of the Go compiler, you're still going to have these results saying that you have libc and the dynamically loaded libraries going through there. And to end it, we're told CGO is not Go by Rob Pike as narrated by Dev Cheney. And we're here at an impasse because we're told to avoid CGO because CGO is not Go, but there is no way I can completely avoid CGO. And I don't know what to do with my builds and my executable. The good news we have is that as Go versions progress, the Go team is working on making the builds more consistent, as we've seen with the earlier example on Darwin, where as of Go 120, the results are more consistent across the implementations and the versions. CGO enabled versus disabled, and the current user versus the non-current user, etc. And this is this is a good news for us that as the Go team works on it, we will have more confidence in the output results that's going to be consistent no matter what I do. And it relieves the cognitive load on us as Go programmers. But this is something that we have to be wary of at the moment. And these are some of the Go 120 changes that are impacting this presentation and the information I've just told you. And there are additional consequences to the CGO enabled disabled, which also checks the whether a C compiler is there or not. And if C compiler is not there in your operating system where you build it, even if CGO is enabled, it's not going to work. It's going to tell you, nope, sorry, I'm out. And on Linux, they used to work around the absence of a C compiler by providing the pre-built binaries or object files with the Go compiler or the Go distribution. This is now gone. They will only provide Go builds. So now, even if you enable CGO, it will not go through those. It will have to build them from scratch, otherwise failing. Now, all of this, studying all of that and researching all of that, it reminded me of The Road Not Taken of Robert Frost's poem. And I changed it to The Build Mistaken, because at every step of my project, I have to stop and say, if I enable CGO here, what is going to happen? And it's not a one-time decision, because at the beginning, you build it with CGO enabled equals 0, and you think that you're avoiding libc somehow. But then you have other consequences down the line where the user lookup is going to fail or not. It's going to give you different results. Now, the DNS lookup is going to change, and it might give you different results. And what's going to happen to my Syscalls? Are my Syscalls going to fail, or is my Syscalls will work as expected? And it's not something that you make a decision at one time and you forget about it. You have to keep it in your mind. You check what the results are, because they're going to change as Go versions build up, and the results will vary widely and it will affect your project negatively. This is not coming out of pure thought experiment. There are consequences to all of this, which is where this came up from. Some of those chose to opt the user lookup for some other their workarounds. The Go team is working currently on that. There are still open issues for that. You can look them up if you want. But the takeaway from this, when you disable CGO, consider the consequences and the results of that and what's going to happen to your final executable, because currently it's not always the same. Thank you.